Well folks, once again it's Sunday, so it's Sierra Hotel 1 Tango set Sunday. Sierra Hotel 1 Tango set Sunday, and I've had another silly mug made. So today's silly mug has a picture of a Sierra Hotel 1 Tango on it, and then it has a picture of a Sierra Hotel 1 Tango radio, which is the Academy CB501. I think I've seen that picture that they've put on somebody. That's my picture, but I seem to think it's on Rig Pics with permission. And there we are, just to remind us it's Sierra Hotel 1 Tango set Sunday. So that's today's mug. This is today's radio, and we're back to a GT858. Last time we did one of these, it did 3 watts, and we only got about 3 miles on it. And I've yet to put that on a different spectrum analyzer to see, because it wasn't losing power upwards, and I was wondering if it was losing power downwards, so I bought a different spectrum analyzer which goes further down. We'll come back to that. So this is got a short lead, so it'll be to the crocodile clips on the bench, so I can short them out at will, and it's got a red sticker on it with our stock number 249, and that means that it doesn't work. Mark has tried it and it doesn't work. Now it's very well worn. It's had years and years of successful use, even though we all think they're dire radios. So I'm going to pause the video and we will open it up. Okay, so with the lids off, it looks in okay condition. Doesn't look like it's had much done in 38 years. There's fresh soldering around the audio IC as if that's been changed, but I may be wrong, and it may just be that they soldered them separately rather than it's wave soldered at the factory. It's had a piece of printed circuit board blowout, and that'll be because it's been reverse polarity, and of course it would have been reverse polarity because the fuse is missing, and that's what happens. So we'll have to make sure the protection diode, which is down there, is actually working. It actually looks like that's been replaced, and if I could find a meter, I can. I had to buy another multimeter because we're working on that Heathkit transceiver that I bought, the HW12A, and because I did the power supply on video, and I need a meter that reads 800 and something volts, and all our meters, unless we start digging out the AVOs, only go up to either 250 or 600 volts. So I can assure you I've only spent £29.99. I wouldn't. We've got an AVO if we want accuracy, and that's the industry standard instrument in the UK. Yes, let's check diode check then on here. So put the meter to diode check mode, and we'll put the probes across the diode, and it should read one way. It doesn't read that way, so it's looking promising, and it reads forwards that way, so that's fine. So that's been changed, so that's something I don't need to do. What we're going to initially do is I'm going to power it up just with the 3-inch stub coming out. I don't want to go to the trouble and expense of putting a power lead on it and then find the radio isn't repairable. We've covered that recently as well. And then I'll do that, and it's quite grubby on the front, and I'll need to just unsolder that can. One of the things to look for when you open one of these up is that resistor there. Let's zoom in a bit. That resistor there it's part of the transmitter chain. It can end up being burnt out, and that can give you low transmit power. And low transmit power on one of these is less than 1.7 watts, because believe it or not, the OK is between 1.7 and 3.5. It's not actually a 4 watt set, it's 3.5, but very few examples achieve that. This is the El Cheapo model, because look, it doesn't even have the extension speaker socket. There are some of these that do have the extension speaker sockets. You can imagine with 1.5 watts of audio, which is all this produces, and without an extension speaker socket, it's not very good if you're wanting to drive a lorry. So Yep, I will. I can see all these parts are going to go through the dishwasher, but I can't see any stress on any of these components. And it always makes me wonder, because they do the 858 with the 2 knobs, they do the 868 with the 4 knobs, and they're all this width. Why didn't they make a slimmer set and take advantage of the fact this board isn't as big as the chassis? I just think they missed a trick there. Right, so I'll get it into a state where we can connect it up, and I will make up a microphone and put a plug on suitable for Great. And remember, when I say Great, it's the brand. It's not, I'm not making a statement about the quality of the radio, because that's anything but. Okay, so I've wired a mic, and just for those of you who may not know, we use this particular diagram, which is blown up to A3. I don't know whether it was Knights at Curtin and Lindsay did this, but it's a jolly good diagram, and it's diagram 4 on this. So this is with the solder pins towards you. So I've now got the cover. Oh, it's an old mic, but I've now got the cover on. So you've got the notch to the bottom. So it's receive, which is normally the black wire, PTT transmit, which is normally the red wire, audio, which is normally the yellow wire, and screen, and that's it on that. So it is great, and again, that doesn't mean it is great. So we'll plug that mic in. And then we'll connect this to the crocodile clips, which are down to the bench, which, because it's only a 3-inch lead. These are the crocodile clips that I have in the past said I really enjoy shorting out. I like shorting them to chassis as well, because I get comments to that. Okay, so let's see what happens. On the odd occasion they don't short out. Oh, well, it's on channel 1. When I worked in Nottingham, there was a good buddy there who was called Count Dracula, and he'd be 19 Count Dracula, yes, take it down to the basement, he would say in his deep voice. So we've got no meter lamp, which is fair enough, and I better just plug the aerial into the test equipment. I nearly went for transmit. It would be very nice if I could plug an extension speaker in, but as I say, there's no socket for it. And I tell you what, it transmits, and it's doing just under 3 watts. Right, I'm going for a lunch break. And I tell you what though, I just said I've looked at the parts and nothing seemed to be dodgy. Just try and get, I forget I can move this camera. There's a capacitor there, which is in the power regulator department, and the heat shrink, which is on the capacitor, if you look at that, it's receded. So that is going to have to be changed, but I'm not going to change it this second. And I can also see something's happened down here. This is as if a capacitor's exploded. So it might be something that's happened in the past, because if you put more than 12, if you put more than 15 volts in, one of these capacitors or more could explode. So I can't see anything in here that has done. So it's quite possible that it's been changed. It was probably that big one there, and it's been it's been swapped, but they didn't clean it up. Not that they have to. But I can't see anything with no terminals. It goes everywhere when they explode. Right, I'll go to lunch. So we'll start with transmit, and we've just about got full scale deflection there, and we start with L207. Just move that so we can just, it's the one to the right there. I've got that right at the end of the 3-watt scale. L4. L5. L6. L7. Right, we'll move over to the other scale now. So bang on the 3 watts. L8. Just move that down so we can see L8. L9 with the green hexagonal tool. And L11, which isn't adjustable. L12. Just have to wait for the soldering iron on that one. Where's the metal tool? No, it doesn't want to move. Right, we'll just backtrack on that one. Okay, 3.1, it's quite good. And there we have it, 3.5. So, and that's when the set's hot, so it's probably a little bit more than that when it's cold. In fact, we can take the power supply up a fraction further, because it's 13.6. Just pop that to 13.8. Yeah, 3.6 watts. Okay, well, that's more than the manufacturer says it'll do. So let's see what the meter reads, if we can see that with no. And it reads, it should be halfway into the red zone. I know it's difficult to see without the meter working. So if we go to RV 4, which is the preset in the screening thing. That's in halfway in the zone. Now we'll check low power, so I'll go over to the 3-watt range, switch to low power. It's ideally it'd be 400 milliwatts, but it's not adjustable on these, and it's 240 milliwatts. So that's not unusual for it not to be brilliant. Now we'll do deviation SVR3, which is just there. So key up the radio. While get the little meter, oscillator I mean. Wallow. There we are, that's 2.2 with an absolute peak of 2.5. So that's that. So now we just need to do the frequency. I'll just tell you where that is before we switch the camera on. It's 2779138, which is of course virtually spot on. It should be 79125. And I just have to look at my notes as to which one the frequency is. It's going to be CT201. So CT201 is the red trimmer to the right, and so we'll key up and see if we can adjust that a bit closer. There we go, 79126, that's brilliant. And the other one's to do with the VCO, but the VCO isn't out on this radio, otherwise there's a fun procedure there. So we're going to move over to receive, and we're going to have to add some more crocodile clip leads because, as I said before, there's no extension speaker socket, and we need to set up the test instruments onto the extension speaker socket, which it doesn't have. So I'm going to have to just crocodile clip lead this, which is really frustrating. Onto the speaker leads. Now, I don't know whether we need 1 or 2, we'll find out in a moment. Yeah, we need 2. Right, so we're listening to actually 0.3 of a microwatt. That's incredible. It never did lack sensitivity. So we'll go down to 4 decibels, and that's my glasses on the floor, and we're doing this with the cyanide only method, not with the sweep generator. I've said before, the two adjustments down here under the wiring there are to do with the detector, and you need to do a sweep generator, but using the cyanide meter we've eliminated the hassle and cost incurred in the time that takes. So we're just going to go through L123 T12T to T1T2. So it's L. I'll just move that so we can hopefully just see. So it's L1, L2, L3, T1, T2. So here we go. So that was already spot on. Do you know what? I don't think this has been messed with on this set. Gained a fraction there. Change to the yellow tool. T1. T2. Okay. T4 and T5, which are these ones here. Just go back to that one. I did change that capacitor, which was down there. It's now a black one. I don't know what T3 does. Can't see it mentioned in my notes. Can't do any harm. No, it's actually gone up one. Okay, so that's where we are. Not really much of an improvement, but you couldn't really improve much from there. I mean, this is 0.1 of a microvolt we're talking about. So let's get a figure for that. We'll start off at 20 decibels. I'll just rescue my glasses from the floor. So they seem to like quoting 20 decibels at the moment. For 20 decibels, the radio is doing 0.85 of a microvolt, which is absolutely unbelievable. I think it was 6.5 on that Midland 4001. Then, if we look for 12 decibel cyanide, which is one of the other points, it's doing 0.25 of a microvolt. And we'll change scales and give you 10 decibel cyanide. And we're looking at 0.25 for 10 decibel cyanide. Absolutely unbelievable. Well, this will certainly hear scratchy corner. But of course, these were notorious for bleed over back in the day when everybody and the dog had a silver rod on the house. So we're back to an S9 signal, which is on a CB radio in the UK, 100 microvolts. Not so on a ham radio, that's different. And if we can see the meter, it's about in that direction. But I think we can see. I'll tell you what, I'm going to change the meter lamp first. I just can't see it well enough. So we'll pause the video and I'll change the meter lamp. And I'll tell you what, I'll put all the front through the dishwasher. So I'll be back to the video in 45 minutes. Okay, so we've been through the dishwasher with it. And the good news is that the knob inserts still had the plastic on the meter lamp. And that's what we were trying to do. We were trying to set S9. So, as I said, there's 100 microvolts on the signal generator, and I can now see that 9 is just there, so it's a little bit high. So, back to the notes. I've also done the power lead on this radio with an inline fuse holder, as it should be. So, just check the adjustment. SVR2, which is the lower one, is the S meter. So I'll use the yellow tool on that. And that's as low as it goes. Now these sets S9 must be something else. And there are some CBs out there with S9 equaling anything, including 10 microvolts. Let's see what it is. So S9 on this radio is 25 microvolts. So everything looks better than it really is. What a trick. So that leaves us with the squelch. So I'll turn the signal generator off and the squelch to threshold. So we'll switch the signal generator on. That's 0.3 of a microvolt. Sorry, switch it on. That's 0.3 of a microvolt, and it's just there. It is just there. So now we'll advance the squelch up to full, and we'll adjust the signal generator 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts. I want it stronger than that. I want it to be 30 microvolts. I want to be stronger than that. I want it to be 100 microvolts if possible before it comes in on full. So it's SVR1. So let's leave the tool in there, move the signal generator up. Now I want it to be on at 100 microvolts. There we are, we're set. And I'll just recheck the bottom end. Once again, switch the signal generator off, squelch to minimum, and switch on the signal generator, and it's just there at 0.3. So that's set great. So we've got a 3.6 watt set. We've got excellent sensitivity. We know they're a bleed over box, but we don't care. And I don't know what I just dropped on the floor, but I did. So I've put the screening cover back. I've done that lead. I've done that capacitor. There we are. It's one of the better. We'll see on the air test. It might be atrocious. So all I've got to do now, because I've had the lids through the dishwasher, is I've just got to. There was a piece of carpet tape there, and I think we'll just go with that with isopropyl alcohol as well, because that can dissolve it to some extent. I'll use Mr. Chippy's toothbrush again. Mind you, that's still got flux on it. It doesn't really matter this, because it's our set anyway. But and I'll get a cloth from somewhere and wipe that off as well. Okay, so with the lids on, let's plug the aerial in. Just check it's still doing some power. Or what, on low power? Okay, so that's all fine. So it's on the aerial now. Well, we'll try it. 1919 a Roger. Never does work. Anyway, we'll do a on the air test with that. We know it's very sensitive. We know it's doing 3.6 watts. So that's about the most satisfactory. And what am I doing the aerial for? That's about one of the most satisfactory ever GT858s. But will it do our 6-mile test route? Well, we'll find out later. So that is the Cheiza GT858. And that's from 1981, and this is Sierra Hotel 1 Tango set Sunday, because that's a Sierra Hotel 1 Tango set. Thank you for watching.